course on embedded system aims at introducing you to the whole world of what is known today as ubiquitous computing. We compute everywhere, wherever or even on the move we are computing. All the gadgets, most of the gadgets that we have in at our home are often connected. We are talking of an era of Internet of Things, where most of the things around us will be connected, amenable to accepting commands from some remote location, and so computing will be everywhere. At the core of such ubiquitous computing lies embedded systems. Embedded systems are systems which are embedded in a larger system. So, in order to learn embedded systems, we have to learn the entire system as such, not only hardware and not only software, but both hardware and software together. In this course, we will introduce you to the basic requirements of an embedded system design. We will next look at the different design constraints that we must meet. This will be followed by a look at the family of processors and different types of programming systems that can be used for embedded computing. This includes general purpose processors, two application specific integrated circuits. All of these have got their own advantages and disadvantages. We will have a look at those. Next, we will move to the design of basic hardware, although we will not go into very much details of hardware design, but we will keep you abreast of the different issues of the hardware design. We will illustrate them using a very well known tool and technology, field programmable gate arrays, as well as with microcontrollers. We will have some demonstrations and examples of designs based on FPGAs or field programmable gate arrays and microcontrollers. Next, we will move to the software aspect. Now, in between the hardware and the software, we will also discuss how to specify a system. A system has to satisfy a number of constraints. The constraints can be time constraints, the constraints can be cost constraints, and there may be other things as well. Now, in order that we can very unambiguously specify our requirements and the specification can be enunciated, we will expose you to some languages and tools, but by which such specifications can be made. Once such specifications are made, we would like to translate them into some parts in hardware and some parts in software. So, once this hardware and software are designed, then we need to test them. We need to test, because you see that if you think of any critical application nowadays, if you look at the launchers, the satellites that our Space Research Organization are making to take off, all these have got at the core embedded systems. Therefore, each of these things must be very reliable. That is one aspect. The other aspect is, if we look at the medical electronics, a lot of critical surgery is being done in a sort of automated manner. At the core of the system is again an embedded system. Now, we cannot have the liberty of having any laxity in their requirements. It has to be very correct, it has to be reliable, it must adhere to the time for which it is desired, it has been designed for the time. So, those are hard timing constraints. All those things need to be taken into account while designing, and these also need to be taken into account before I put them to the market. That means in between I also need to test them, simulate them and verify them. So, if I do all these, and if during the testing or verification I find some gaps or some specifications that have not been met, then I will have to go back to my original design and revise this design. So, this course will expose you to all these critical aspects in the life cycle of an embedded system design, and you will be in a position to understand what an embedded system is, and it is hoped that in your work life, if you are given an assignment or task to take up based on embedded system, you will be ready to do that. কতক্ষণ হলো?